Hi class, today we're going to continue and we're going to talk about linear functions today. So what are we going to talk about? Now we're going to talk about a specific type of function, linear functions, okay? And remember when we talked about linear equations, well, we're going to talk about linear functions. So it's going to be very similar to what we did with linear equations, but now we're going to be talking about functions. So we're going to talk about we're going to talk about the basic concepts of linear functions. What the standard form is, which is this form of a function. We're going to talk about the slope of a linear function, average rate of change, what is that? Okay, and then linear models. We're going to talk about linear models. Okay, so now linear function. So a function f is linear if it has this form, ax plus b, right? Just like when we were talking about linear equations, because remember, we had linear equations, so this looks very similar to a linear equation, but we're talking about the specific relationship of a function. And by the way, all linear equations, right? Now, in linear equations, we were talking about linear equations in one variable, but now we're talking about two variables, okay? But you can definitely tell that it's linear because it has that same form, right, that we saw before. So f of x equals ax plus b, where a cannot be equal to 0, because if a is 0, then we no longer have a linear function. You just, oh, actually, no, I'm sorry. No, I'm sorry, I almost misspoke. So a could be 0 because a constant function is a linear function. It's just one where it's not very exciting. But anyway, so in this case here, the graph f of x equals negative 2x plus 6, we're going to give the domain and the range. So now, because this is not 0, we know that the range is going to be all real numbers and the domain is all real numbers. Okay, in fact, for any linear function, the domain is always going to be all real numbers. And if the leading coefficient here, negative 2, if this leading coefficient is not 0, then the range will also be all real numbers. Okay, if it is 0, then the range becomes one value, which is whatever this constant is. Okay. Okay, so now the x-intercept, right? Remember, the x-intercept is found by letting f of x equal to 0. Remember, we let y equal to 0, but now we're using f of x instead of y. So f of x is equal to 0. So then we solve for x, and we find that the x-intercept is going to be located at 3, 0. Okay, and the y-intercept is going to be found by letting x be equal to 0. So if x is 0, then we get 6. So the y-intercept is going to be at 0, 6. Now we plot this point and we join the 2 points with a straight line graph, and then we use the point 2, 2 as a check. Now you don't have to do this, but you could. If you plug in 2 into this, do you get 2? And the answer is yes. And so here's the graph. So here's the y-intercept, here's the x-intercept, here's your checkpoint, and then you draw your straight line. And the domain and range are both negative infinity to positive infinity, just like I had mentioned before. And you can see that now from the graph easily, that it's all real numbers for both the domain and range. Now, what we want to do is we want to graph now f of x equals negative 3. Now notice that there's no x in here. Okay, so if we write this, we can write this as 0x minus 3. Okay, this is a constant function, right? So this is just going to be what? A horizontal line at y equals negative 3, right? F of x equals negative 3 is going to be just a horizontal line. So this means that the domain is going to be all real numbers, but the range is going to be the one number, negative 3, because y is always going to equal negative 3 no matter what x is. And so we get the horizontal line of f of x equals negative 3. and it intersects, right? So there's only one intercept. It's the y-intercept, and it intercepts at what? 0, negative 3. Now, x equals negative 3. Now we're talking about x equals negative 3. So think about this. There's no y value. There's no f of x. That means that no matter what y value you choose, y doesn't matter. So that means no matter what y value you choose, whatever you want to make f of x is always going to stay the same. It's going to be negative 3. So that means if you think about it, if you go up and down the y-axis, you know that no matter what value of y you use, x is going to still be at negative 3. So this is going to be a vertical line, right? So since x always equals negative 3, the value of x can never be 0. So therefore, there's no y-intercept for this case. The graph is parallel to the y-axis. That's another way of looking at it. If there is never going to be if x can never be 0, right? We're talking about linear functions, and this is a linear function. Then we're talking about a line that is parallel to the y-axis, so it has to be vertical. And so in this case here we have a vertical line, and the x-intercept is negative 3, 0. Okay. So in this case, the domain is what? The domain is negative 3, one number. But the range is all real numbers. So this is not a function, and especially if you look at the vertical line test, if you write the vertical line right down this line, you get an infinite number of what? You get an infinite number of y values for just one x value, which violates the definition of a function. So this is not a function. So in this text, what we're going to do is we will agree that if the coefficients and constant in a linear equation are rational numbers, then we will consider, okay, so here we have, what was I saying? Right, okay, so if the constants and the coefficients are rational numbers, then we will consider the standard form to be this. Okay, so again, so we're going to agree that if a, b, and c are rational numbers, this is going to be the standard form for a linear function. Okay, where a is going to be greater than or equal to 0. Okay. A, B, and C are integers, and the greatest common factor of A, B, and C is 1. Okay, so that's what we're going to assume is standard form. Okay, so A, B, and C are integers, and then A has to be greater than or equal to 0, so it can't be negative. And A, B, and C are all, the greatest common factor is 1, which means that they have no common factors. Okay, so everything is in lowest terms, right? So you can't factor out anything, and A is not negative. So if that's the case, then we're going to say it's in standard form. Okay, and when we say that they have no common factors, we call that they're said to be relatively prime. So we want to graph this and give the domain and the range. So this is in standard form. Okay, so what we can do is we can find the intercepts. So if we have this in standard form, we can just find the intercepts. So again, if we want to find the y-intercept, we set x equal to 0 and solve for y. If we want to find the x-intercept, we set y equal to 0 and solve for x. And so we can find those intercepts by doing this, like doing that. And so here we find that the y-intercept is at 0, 0. So it goes through the origin. So the y-intercept, in fact, the x-intercept is also through the origin. Okay, and in fact, you don't even need to solve, because if it goes through the origin, then we find that the x and y-intercepts are the same. Okay, so this means that the graph, the line, goes through the origin. Okay, so there's just one intercept. Now we're going to find an additional point, because since we only have one point, then we just need to find an additional point. So we can just pick a value for x and find the corresponding value for y, or we can pick a y value and find the corresponding value for x. So it doesn't really matter which way you go, just pick one. So here they pick 5. Plug in 5 for x and see what you get for y. In this case, we get 4. Okay, so now we get the point 5, 4. Okay, so from this we find that what? This is definitely not a constant function. Okay, and so we get 5, 4, or 5, 4. And so the domain and range is going to be all real numbers. Okay, and so we could see that it goes through the origin. If it was a constant function, we would have gotten 0 again for y. If this would have been 0, then we would have known that this was a constant function, and the domain would have been all real numbers, but the range would have just been 0. Okay. Now, what's slope? Slope is a numerical value, a numerical measure of the steepness and orientation of a straight line. Okay, so geometrically, this is interpreted as the ratio of rise over run, or the difference in the y values divided by the difference in the x values. Okay, so to find the slope, that's all we have to do. Okay, and so we use the symbol delta x to represent the change in x. So when we say the difference in the x values, we will use the symbol of delta x, which means the same thing, the change in x. And we're going to use delta y for the change in y. And so rise over run can also be denoted by delta x, or excuse me, delta y divided by delta x. And so the slope denoted by m is rise over run, also equal to delta y over delta x, which is again the change in y over the change in x. And make sure that if you subtract the corresponding y values, that you also subtract the corresponding x values the same way. And again, delta x cannot equal 0 because for obvious reasons we can't have 0 in the denominator of a fraction. Can't divide by 0. Okay. Now, when using the slope formula, it makes no difference which point you make this one, x1, y1, or x2, y2. But again, as I tell students all the time, just be consistent. Okay? Start with x and y values of one point, whichever one you choose, and then subtract the corresponding values of the other point. That's it. Okay? So you can either do this or you can do this, as long as you're consistent. If you do y2 minus y1, then you have to do x2 minus x1 on the bottom. If you do y1 minus y2, then you have to do x1 minus y2. If you do anything else, you're going to have the wrong answer. That's it. Now, undefined slope. If we have an undefined slope, that means we have a vertical line. So the slope of any vertical line is undefined. When does it happen? Well, whenever we have 0 in the denominator. In other words, when the x values are the same. And the x values will only be the same when you have a vertical line. So that's why we call it an undefined slope. So find the slope of the line that goes through these 2 points. So what we're going to do, again, pick a point, and doesn't matter which one you start with, and we're going to subtract off the corresponding y values and x values, right? So remember, it's going to be rise over run, delta y over delta x, change in y over change in x, which however you want to remember it. Okay, so we're going to let x1 be -4 and y1 be 8. x2 is 2 and y2 is -3. And so now we're just going to plug it into the slope formula. So we take -3, right? So if we're going to take, excuse me, y. So if we take -3 minus 8, then we have to take 2 minus -4. And so if we simplify again, this becomes a positive, so this is going to be 6, and this becomes -11. So -11 over 6, or a -11/6. And that's the slope. What about this one? Well, again, let's just plug into the slope formula. So we go -4 minus 7. So then we have to do 2 minus 2, which gives us 0. Since we cannot have 0 in the denominator, this is undefined, which means we have what kind of line? We have a vertical line. Okay. What about this one? Well, here again we do rise over run, so the difference in the y's divided by the difference in the x's. So again, if we start with this one, we go -3 minus -3, which is 0. And then we have -2 minus 5, which is -7. So we get 0 over -7, which is 0, which means we have a horizontal line because the slope is 0. So that tells us, hey, the slope of any horizontal line is 0. And we saw that before because if we remember, the function of a linear function of the form ax plus b, where a is 0, gives us a constant function which is horizontal. So there's a direct connection here. So the slope of a horizontal line is always 0. So now if we look at this one, we want to find the slope of the line 4x plus 3y is equal to 12. So what we need to do is we need to find the slope. Okay, so we're going to solve the equation for y. Okay, and you'll see why. Okay, so we're going to solve the equation for y and see what we get. Okay, so we want to subtract 4x from both sides. So we get -4x over here. Then we're going to divide by 3. And we get y equals -4/3 x plus 4. Notice the form over here. Notice as a linear form. ax plus b. Well, this here is m. So what we call x is actually m, which is the slope. So this tells us the slope is -4/3. Now, what if we want to graph a line and all we know is the point that it goes through and we know the slope of the line? Well, we can plot the point. So we've got one point, but in order to graph a line, we need at least 2 points, right? So a straight line, a linear function, we need 2 points, right? Okay, in fact, that if we have 2 points, we can do it. So the minimum amount of points we need to graph a straight line is 2. So we've got one. How do we get the second one? Well, we're going to use the slope to help us. Remember, this is rise over run. And normally we use the negative sign. We put the negative sign with the top one when we do this. So what we're going to say is we're going to go -5 units in the run direction. So that means in the x direction. And we're going to go +3 units. Or excuse me, I'm sorry, in the y direction. So that we're going to go -5 units in the y direction, which means what? Down. And then we're going to go 3 units in the x direction, which is +3 units, which means we're going to go to the right. So if we go 3 units down and 3 units to the right, we're going to get to the next point. Okay, which means if we take this point and if we go 3 units down, which means we're subtracting, or excuse me, 5 units. If we go 5 units down, we're subtracting 5 from this one. And if we go 3 units to the right, which means we're adding 3 units to this one, what are we going to get? We're going to get 2, 0. Okay? And that's how we do it. Okay? So again, it's just understanding what this means. And so how we interpret rise over run. Okay? And then using that to help us get from this point to the next point. So again, we're going 5 units down and 3 units to the right, which means we're subtracting 5 from y and adding 3 to x. So we get -1 plus 3 is 2, and 5 minus 5 is 0. And we get 2, 0. So that's the other point. And now we can plot those 2 points and graph. So slopes. Now orientation of slopes. So let's think about this. So think of a straight line, or think of a hill or a street, right? Slope of a street, the slope of a plank. Let's say you're on a plank, the incline. Think about the incline of the road or plank. So that's the same thing as a slope of a line, right? So a line with a positive slope rises from left to right. So it's increasing from left to right. Okay? And so if a straight line has a positive slope, it increases on the entire domain. If the slope is negative, that means it falls. It decreases from left to right, and the corresponding linear function decreases on the entire domain. If the slope is 0, then it doesn't fall, it doesn't rise. It's neither increasing nor decreasing, which means it's constant on the entire number line. Because remember, when the slope is 0, as we just spoke about a moment ago, it's going to be a horizontal line, right? And a slope of a vertical line is always undefined. So now guess what? The slope of a line, a straight line, we can also look at as an average rate of change. Okay? So we know that the slope of a line is the ratio of the vertical change in y to the horizontal change in x. So thus, it gives us an average rate of change per unit of change in x. Okay? So we can look at the slope of a line as the average rate of change, okay, between 2 points. So now, if f is a linear function defined on the closed interval from a to b, then we can find the average rate of change by just taking the value of a, right, or excuse me, taking the value of the function at a, which is f of a. Okay, this should be f of a right here. That's wrong. That's a typo. This should be f of a. And we take the value of the function at b, so that would be f of b, and we find the slope, right? So we take change in y, right? The change in the function, so f of b minus f of a, okay, divided by the change in x, which in this case is from one endpoint to the other, so it's going to be b minus a. So b minus a. So f of b minus f of a divided by b minus a. This is the formula for the average rate of change. And it's nothing more than the slope formula. That's it. Because you can easily say that this is y2 minus y1 divided by x2 minus x1. It's the slope formula. But we're now just using it as average rate of change. So now, in real life, let's say we have this. Let's say we have in 2009, Google spent 2.8 billion dollars, right? 2,800 million, which is 2.8 billion, on research and development. In 2013, Google spent 8 billion on research and development. Assume a linear relationship. Find the average rate of change in the amount of money spent on research and development per year. Okay, so we want the average rate of change per year. Okay, so what are we going to do? Well, we've got 2 points. In 2009, they spent this many millions. In 2013, they spent this many millions of dollars. Okay, so now we've got 2 points. We can find the average rate of change by finding this is the f of x1, let's say. This is f of x2. This is x1. This is x2. So let's just use our slope formula. Okay, so here's x and y for the first year, and x and y for that second year. So 2009 versus 2013. And so now what we're going to do is we're going to use these 2 points and use the slope formula. So average rate of change is 8,000 minus 2,800 divided by the quantity 2013 over 9, which is going to be 4. So we get 5,200 divided by 4, so approximately $1,300 million per year. So about $1.3 billion per year is what was spent on R&D, or that's the rate of change. So every year, Google spent on average $1.3 billion more on research and development. That's how much it increased per year for those 4 years. Okay, so the amount of R&D, the amount of money spent on R&D by Google per year increased. So it increased by an average of about $1.3 billion per year. Okay, so now what about a linear cost function? So let's say we have a cost function that's represented by a linear model. Okay, which means we're using a line to model the change in cost, or how cost behaves. So where x is the number of items produced, or widgets or units, okay, m represents the variable cost per item, so, or the marginal cost, and b represents the fixed cost. So the fixed cost is constant for a particular product, right? It does not change as more and more items are made. So again, for example, the rent for the building, right? You have to pay the same amount of rent every month, regardless of whether you produce 0 items or whether you produce 1,000,000 items. You pay the same. So that's part of your fixed cost, okay? Or if you're talking about payroll, right? So if you have a certain number of employees, well, you still have to pay those employees for showing up, whether they produce 0 or whether you produce 1,000,000. So those types of things are going to be considered more of a fixed cost. Okay. Now, but you could also look at that as far as the employees or payroll, because the more employees you hire, the more money you have to pay. So that's going to be it, but that's not a variable cost unless you look at it. Hey, if I'm going to create more widgets, I have to have more employees to do that, I guess. But again, you get the point. So the value of mx, the marginal cost, it increases the more items you produce. For example, labor, right? The labor that it costs to make 1 unit, right? So if you make 2 units, well, it's going to take more labor to make 2 units. Materials, right? Each unit that you create may require more materials, right? So if you make fidget spinners, let's say, well, it takes material every time you create or make a fidget spinner. Okay, or if you create an Xbox, right, you have to have a certain amount of material. It's going to cost more materials for every single Xbox you create. Packaging, right? Each widget goes into a packaging, and so on and so forth. So that's all part of the marginal cost. So now the revenue function is really, it's all about what you're selling the product for. And it only depends on the number of items you sell. Okay? So it depends on the price per item, right? That's it. So the amount of revenue depends on how many widgets you sell, and you're selling at a particular price, okay? And so we assume that that price is constant, so it's really only given by this very simple function. So the revenue function is always a linear function in this case. Again, we're only talking about linear functions, and it's just the price times the number of items you sold. That's the revenue function. So now the profit function is really simple. It's the difference between your revenue and your cost. So in this case, it's always going to be cost minus revenue. Profit is always your cost function minus your revenue function. Okay. So in this case here, they say revenue minus cost. So in this case, again, it really doesn't matter if you do, it's just the sign is going to be different. So in this case, in the beginning, you're going to have negative cost, or excuse me, negative profit. Okay, because in the beginning, you're going to have more cost than profit. Okay, and then at some point, it's going to flip. Okay, but profit is going to be the difference between those two functions. So now here's an example. So we want to assume that the cost to produce an item is a linear function and all items produced are sold. Okay, and we're going to use a fixed cost of $1,500 and a variable cost per item of $100. And then we're going to sell all the items, each item, for the same price of $125 each. So we're going to write linear functions to model the cost, the revenue, and then we're going to figure out what the profit function looks like. So let's start with the cost function, right? So what's the cost function? It's going to be the combination of the fixed cost and the cost per item, or the marginal cost. Okay, so in this case, you're going to take the fixed cost plus the marginal cost. Well, what's the fixed cost? $1,500. What's the marginal cost? Well, that's going to be the amount it costs to manufacture or create or build each item. In this case, it's $100 per item. So the cost function would be the sum of those two pieces. And so it's going to be the marginal cost plus the fixed cost. So in this case, M is going to be what? 100. B is 1,500. And so there's the cost function. That's it. Now, what about the revenue function? Well, that's going to be what? The number of items sold, which in this case is X, times what you're selling them for, which is P, right? So this is going to be P times X, which is 125 times X. So the revenue function is going to be what? 125X. So now that's it. So revenue and cost are done. So now what about profit? Well, now remember, the profit is the difference between revenue and cost. Okay, so it's going to be this. So now if you want to write this out, all you have to do is solve this. Okay, and it doesn't matter if you flip these around, you're going to get the same function. The graph will always be the same. So in this case here, we just plug and chug, right? So we're going to plug in revenue, so that's 125x, and we know we're going to subtract off the cost function. Now the cost function is this entire thing. So we're subtracting off this entire thing. So we have to have the parentheses around here, right? So make sure you don't forget the parentheses, okay? Because we're subtracting off both pieces. So this is going to be subtracting off 100x and then subtracting off 1,500. And so now we just combine like terms, and we get the profit function is going to be 25x minus 1,500. Okay? So that means if we don't sell any widgets, we're in the negative. We're out of pocket $1,500. Okay? Or wherever the case may be. Okay, well, in this case, it's $1,500. Now, D asks, how many items must we sell in order for the company to make a profit? Well, first we have to find out what's the break-even point. Well, what's the break-even point? That's where profit is equal to 0, right? Or another way of looking at it, it's the number of widgets that we need to sell where the revenue and the cost are equal. Okay? If revenue and cost are equal, then profit is 0. So same thing. Okay, just another way of looking at it. So we start by finding out where is it 0, because then we know that anything above that X value will answer our question of profit, because if it's 0, we didn't make any profit. Okay, profit is 0, we didn't make any profit. Okay, and then so if we start with finding out the break-even point, then we know that any number of widgets above that amount will give us profit. Okay, so now we start with the equation, right? And we set this equal to 0, right? Or we can look at the inequality where profit is greater than 0. Either way will work, right? So you can solve the inequality and be done. So that'll work too, okay? 6 half and a dozen of the other. So now we're setting up this inequality. So we want to know, when is this greater than 0? So all we have to do is solve for x. And so we add 1,500 to both sides. And then we're going to divide by 25, or x has to be greater than 60. Okay, so x turns out to be greater than 60. So anything greater than 60, we will have a profit. If x is equal to 60, then profit is 0. And if x is less than 60, well, now we have a negative profit, or we're losing money. So 61 items or more must be sold for the company to make a profit. Okay, so that is the end of this section. So again, make sure you're working through suggested homework problems, work on the homework. Again, even though we're going to be doing this in class as well, part of the process is going to be also working on this on your own, because remember the 2 to 1, right? For every hour you spend in class, you should be spending 2 hours outside of class. So even though we're going to be spending time inside of class doing homework, practice, answering questions, and so on, you're still going to be expected to be doing it outside of class, even though you're watching lecture videos. So again, it's not about more work, it's just about being different, okay? So again, as you're practicing, write down your questions, bring those questions to class, or email them to me. If you get stuck on a problem, let me know what problem that is, or bring it to class and we'll work on that problem. Either way, if you email it to me, we may go over that problem in class as well. So again, the more you engage me, the more you basically ask questions and engage me, the more this is going to be a benefit to you. So I encourage you, please do that. Okay, have a great day. I'll talk to you later.